everyone, welcome to day 7 of Honest Interview Preparation. Today we will cover Prefix Sum, a simple idea that interviewers use to test whether you can optimize repetitive work. This is less about code and more about recognizing patterns. Let's begin.
The problem is, we are given an array and multiple range sum queries. Each query asks for the sum of elements between two indices L and R inclusive. Here array stays the same, but we are asked to compute sums for many different ranges. If we calculate the sum from scratch for every query, we end up doing the same work again and again. The brute force approach is straightforward. For every query, we loop from index L to R and add all the elements in between. Here's the pseudocode for that. We initialize a variable s to 0 and loop from index L to R plus 1. Add the elements in between and then finally return the value of s. Now this has the time complexity of O of n for every query. Let's say if we have 1 lakh elements in an array and 1 lakh queries, then the time complexity will be O of n 1 lakh times. This works correctly, but the time taken for each query is linear. So when the number of queries increases, this approach becomes inefficient. The key insight here is that we are computing the same sums repeatedly. Instead of recalculating partial sums for every query, we should compute them once and reuse them. This is a very common interview pattern. Avoid repeated work by pre-computing results. We create a prefix sum array that stores cumulative sums. At every index I, prefix I contains the sum of elements from 0 to I index. So at 0, we have the element as 2. At index 1, we have the sum of 2 and 4. Index 2, sum of 2, 4 and 6. Index 3, sum of 2, 4, 6 and 8. And at index 4, sum of 2, 4, 6, 8 and 10. Once this array is built, we already know the sum up to any position instantly. As an example, the sum up to index 4 is 20, the sum up to index 5 is 30, and so on. To calculate the sum from index L to R, we take prefix R. However, this includes the sum of elements before L as well. To remove that extra part, we subtract prefix L minus 1. Let's take an example. If we are given a query to return the sum from index 1 to 3, we have already computed the sum up to index R in the prefix array. So the sum up to index R is 20. But this sum also includes the element at index L minus 1. So to remove that extra part, we subtract prefix of L minus 1 from prefix of R. This subtraction isolates exactly the range we want. There is one important edge case. When L is 0, there is no prefix before it to subtract. In that case, prefix R already represents the current sum. Let's say we are now given a query with L 0 and R 3. In this case, if we use the above formula, prefix of R minus prefix of L minus 1, we will get an index error because there is no index L minus 1 here. So we will just return prefix of R in this case. Mentioning this explicitly avoids index errors and shows attention to detail in interviews. Now that we are clear with the logic, let's proceed with the walkthrough of implementation. We first create a prefix array having length of nums array. Initialize the first element of prefix array with the first element of nums array, and at each index store the sum from 0 to that index. This pre-processing takes linear time. For each query, we subtract L minus 1 from prefix R to remove the extra part. This allows each query to run in constant time. So the overall time complexity remains O of n. Let's run the code. So this is the expected outputs. Now let's walk through the complexity analysis. Building the prefix sum array takes linear time. Each range query can then be answered in constant time. So we trade a one-time O of n pre-processing cost for very fast queries. This trade-off is efficient when the number of queries is large. Interviewers are not testing prefix sum itself. They're testing whether you can recognize repeated computation and optimize it using pre-computation. Common mistakes include recalculating sums for every query, forgetting the L equals 0 case, or not explaining why subtraction works. Clearly explaining the reasoning often matters more than writing the code quickly.
That's day 7 of honest interview prep. Prefix sum is a small idea, but it appears everywhere in interviews. If this helped you, follow along as we continue building clarity step by step. See you in the next one.